Alrighty. A couple things before we get going. Those of you that missed, Friday, make sure that you requested whatever you need. Those of you that were here on Friday and turned in your homework, so that should be last homework assignment for the year. So now there's a good side and a bad side of that. The good side is that there's no homework for the rest of the year. The bad side is basically, except for that homework assignment and your geometry test and your Unit 10 retest, if you need a Unit 10 retest, your grade is your grade at this point. Okay? So you should be able to check back and kind of see where you sit with regard to your grade. If your grade is not where you want it to be, then cash is probably the recommended form of currency with regard to bribes. I don't like checks because there's way too much of a paper trail. Gift cards are still a little bit of a paper trail, but cash is probably your best. Coins? Okay. Coins is fine as long as the coin number is worth my time. I mean, if you're bringing like a wheelbarrow full, then I'm good with that. If you're bringing me like a couple of rolls of pennies, I'm just living away. Wait, you're for real? Like you're serious? Yes. So like how much? I can't name a price. I'm just suggesting that if you, it really depends on where you are. If you're looking, if you need like 3/100ths of a point, that probably has one value. If you're needing like 8, it's probably a whole different kind of value. So, you know, throw that out there. Remember that we have 5 days this week, 4 days next week, and 3 days a week after that. On the last week, those 3 days, the first 2 are spent on your EOS exams. Okay, we have end of semester exams, Tuesday and Wednesday, the last week of school. So kind of be aware of that. I'm not providing a review. If you want to review, the whole EOC folder is still online, and you can review that stuff. That's basically what it is. It's an end of year test for algebra. None of the geometry is on the end of semester exam.
Wait,
okay?
Like, is it a grade?
The end of semester exam, 1/7 of your semester average.
Oh.
Yeah, guys, this is a quick reminder. So in high school, the way your semester average is calculated, which, by the way, is what they base your grade point average on. Your GPA is calculated based off your semester averages. The semester average, they take your first 9 weeks of the semester, they multiply it times 3. They take your second 9 weeks average, they multiply it times 3. That gives you 6 grades. Each 9 weeks has been multiplied by 3. Then they add in your semester exam, divide by 7. That's your semester average. So that means your exam is 1/7 of your semester average.
So is it like the Spanish one?
So it's what like the Spanish one? Is the Spanish one a high school class?
Yeah.
Or why are you asking me that out loud?
I'm scared.
All high school semester exams are calculated the same way. Any other questions? Okay. All right. So it says the graphs of the three lines given below form a triangle. Use the graph to find the coordinates of the vertices of the triangle. What should we do right off the bat in order to graph these lines? Standard form is only good for one thing. Anybody remember what that one thing is? Finding your intercepts. Finding your intercepts. Now, standard form is not just an annoying version of an equation that you have to change. If you want to find the y-intercept, all you have to do is make x equal to 0. When you cover up x, it says y equals 8. And then when you want to find, the x-intercept, which is where the y value is 0, 2x equals 8, x equals 4. That gives you the 2 points you need to graph the line. 1, 2, 3, 4, 5, 6, 7. There's 1 point, there's another, and that's your line. Just so you know. Okay? Now, if you converted it into slope-intercept form, that's another way to do it. I'm just saying this is a faster way. So don't forget that the standard form of an equation has a purpose. You can go ahead and change the slope-intercept form. Jackson, if you change the second one to slope-intercept form, what did you get it?
Y equals 1/2 x minus 2.
Perfect. Y equals 1/2 x minus 2. We start at -2. We go up 1/2. So we end up 1/2. We end up with that line there. And Great, what did you get for the third one?
Y equals 3x plus 3.
Y equals 3x plus 3. So we go from 1, 2, 3, and we go up 3 over 1, down 3 over 1, down 3 over 1. Which basically gives you triangle here, here, and here.
Yeah.
Right?
Yes.
Gives you the triangle formed by those. And the vertices, Wyatt, are located where?
-2, -3. 1, 6. 4, 0.
Okay. Any questions on that? All right. Okay, so today we're going to get into simplifying radicals. And we've already done a little bit of this already. Earlier this semester, we talked about how to simplify radicals, and there was a process for this. What's the first thing I wanted you to kind of think of in your head whenever you're simplifying a radical?
Is it a perfect
The
square?
good square root, bad square root test. Remember? So we're going to split the two square roots into a good version and a bad version. And on the good side, you want to pick the largest good square root, the largest good square root that goes in to your number. You might remember the cheat, how you can like find it without really having to add the multiplication skills? Yes.
Is it, use a second and then,
Go to y equals, type in 88 divided by x, go to your table, look on the y side. Look on the y side. So when you type in 88 divided by x into y equals and you hit the table, it should have 0 as your first one. It'll say 0 error. That's where you start. And then it'll run down your list. It'll say 188, 244, it'll say 3 and something, 4 and 22, 5 and what? 17.6, 6 and okay, so blah 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 blah, right? What you do is you look down the y side until you come to the first good square root. You go down the y side until you find the first good square root. And this one, it actually gets you all the way down to 4 times 22. 4 is the first good square root on this factor list. The square root of 4 is actually plus or minus 2, but for the purposes of today, don't worry about writing plus or minus, but keep in mind that every square root has 2 answers. So you end up with 2 root 22, and that's your simplified version. Okay? Any questions on that? Same thing here, you split, good, bad. Type it into the calculator if you need it. Look on the y side, you'll find out it's 16 times 5. The square root of 16, 5 root 5. Okay? What about 3?
wait, wouldn't it be 4?
More.
Yeah, right. Oh my gosh.
I thought it was
I know.
Hey, what just happened?
Square root of 45.
9.
9 and 5, which gives you 3 root 5. Square root 9, square root of 5. Okay? And the square root of 65. Talk about the calculators. Yes, you're right. There isn't one.
Yeah.
Therefore, the square root of 65 is the simplified version of the square root of 65. The square root of 65 is what is called a prime square root. The prime square root is one that cannot be simplified. Okay, yeah. Well, no, you would just box it. If it said simplify it, you would put a box around it. In algebra, you'll add a plus and a minus before you simplify, before you box it. Because it's both a positive and a negative still. Okay? Any questions on that? Okay, so then we're going to do these now. Now, I want to talk to you a little bit about this so that you kind of get it. And then most kids, once they hear this, then it becomes a little bit more understandable. If you have m to the fifth power, and you multiply into the fifth times itself, which is into the fifth, what do you get?
To the 25th. Oh, the 10th.
Into the fifth times into the fifth is into the 10th, because you add the exponents, which is what we've done since unit 1. Yeah.
You add them.
If you have y to the third squared, y to the sixth. If you have r to the 13th squared, r to the 26th. And what that really means is that the square root of n to the 10th is n to the 5th. Because the square root is going the opposite direction. The square root of y to the 6th is y to the 3rd. So what do all these perfect squares have in common?
They're all even.
They all have an even exponent. Basically, any variable with an even exponent is considered a perfect square root. You can find the square root of d to the 24th. You can find the square root of x to the 36th. Okay, as long as the exponent is even, then you have a perfect square root. So when you get to something like this, then we're still going to split it. Good side, bad side. Good side, bad side. Good square root, not good square root. The way I want you to deal with it is I want you to go one piece at a time. So we're going to start with 63. We're going to split 63. Good square root, bad square root. So what good square root goes in 63? 9. So we end up with square root of 9 on the good side, square root of 7 on the bad. Now, here's what I need you to pay attention to. When you have 8 in the fifth, is it a good square root or bad square root? Bad square root is odd. What's the most number of a's you can take out of a to the fifth so that you can put them on the good side?
1.
You can split a to the fifth as good side, bad side. Is a to the fourth times a to the fifth? Okay. So is a to the fourth the good square root?
Yeah.
Then I'm good. Josh? I know, but this is day 1. So stop fixating on that and just pay attention. Do what?
Yeah, that's why you hurt your foot playing basketball.
Pay attention? Okay, good. Okay. B to the 8. Is B to the 8 the good square root or bad square root? Good. So it all goes over here. And C to the 11th. Okay, so how many C's can I take out and put on the good side? 10. So I put C to the 10th on the good side and C on the right.
Okay, I see.
Huh? So all I've done now is split it into good square roots and bad square roots. So now I need to take the square root of all these numbers. The square root of 9,
3.
square root of a to the 4th is a squared, b to the 4th, c to the 5th, and if you get it right, all this on the right side stays under the radical. You have a back, Josh, use it.
So basically, whenever you're like moving them, the ones on the right will always be 1.
Or they won't be there. You weren't fixating on the 1, 2 thing, you were, look, shiny up. All right. So on number 6, we're going to split it again. And if you want to write these on the back of your day 2 notes, you're welcome to do that. So we're going to split these again. Good side, bad side. First, we're going to split 72. What? 36 and 2. Hello.
When you doing this, just regular X.
I'll show you that in a second. That's a good question. Okay, so we have 36 times 2. That gets us to 72. We're done with that. Now we'll go to the x to the 9. How many? X to the 8 and x. And then y to the 4th goes all on the good side. And now we have to find the square root. Square root of 36. Now listen carefully. Before we do that, let me back up. What's the square root of x to the 8? What's the square root of y to the fourth? Now, I will tell you what a lot of kids will do because they're going too fast and they realize that on the exponents, they're just cutting them in half. They'll just take the number and they'll cut it in half. Don't do that. Square root of 36 is 6. So make sure you get this down. And then root 2x stays on the right. Okay? Try that.
Oh,
Mr. Smith,
Yeah.
once you get to like if they gave you a multiply by the whole.
Do what now? Yes.
Okay.
This is the rest.
Figure out where they came from.
What came from?
Those things.
Oh.
Last year, the Christmas celebration fell right in the middle of everything.
I remember catching that last week, and then I totally forgot.
What happened to that? Alrighty. What sheet? Okay. So I will show you kind of the way that I would recommend it. This is just the way I do it. It's not the way that you have to do it. When I have a coefficient out front, I'll usually write it and then just split everything in parentheses so that I can make sure I keep up. Because I always forgot to bring that down. Always. So I would do this, and then I would split it into good square root, bad square root. So we have 100 times 3. Okay, so here we are, Logan. How do you make p to the first a good square root? You do not. It just stays over here. Okay? Now, q to the 7th becomes q to the 6th. Q, I hate q. Because you can't write them very well. They look like 9. Okay? So there's your split, which gives you -2 times 10 q to the 3rd r root 3pq, and then you do this, so -20 q to the 3rd r square root of 3pq. Any questions on that? Sure. Yeah, basically what it means, guys, is when you have a coefficient out front at the very beginning, that coefficient ends up getting multiplied times the good square root guy once he becomes like a normal number. Okay? The coefficient basically gets multiplied times the good square root once he becomes a regular number. So I'm wasting time. Okay, here we go. Hey, I'm handing out like notes that actually match this time because we still have a couple more to do.
Okay.
So if you do want those. Well, these are going to actually match what I just eyebrow. As opposed to.
Mr. Smith, I said I like that.
I was putting it on your desk.
When you do the day 2,
Yeah. It's right there. Okay. Any questions on that? Does anybody want to just copy this down really quickly on the notes that just gave you? Most would be able to do this, and I can bring this back up in a second. You can kind of cross-check it. Now, does anybody remember what the rules are with regard to adding and subtracting rationals? They have to match under the square root sign in order for you to add or subtract. In other words, you can do 2 root 3 plus 5 root 3, but you can't do 2 root 2 plus 5 root 3. The root part must match. The roots part must match. So basically what that means is this and this have to match in order for them to be like terms that you can add or subtract. Now, can 5 root 7 be simplified? No. It can't, but 2 root 28 can. Yeah. So come over here to the side and just do 2 root 28 and do your split again. Remember, it's 2 times the square root of 4, square root 7. Good square root, bad square root. Square root of 4 becomes 2. So this whole thing becomes 4 times the square root of 7. 2 root 28 becomes 4 root 7. Which means that up here, we have 5 root 7 minus 4 root 7, which is just root 7.
Yay. I'm not asking this question a lot. Do they matter if there's a 1 in front?
No. They shouldn't count it wrong if you put a 1, but I can't guarantee that because some teachers are. Yeah. But mathematically, it doesn't matter at all. Okay?
Would you take points off if we did it?
No. Oh my gosh. No. No.
Why do you say off? What is wrong?
So on number 9, now I want to talk about this just really quickly. When you're doing these, I would do this, and then I would rewrite it as a subtraction problem. I would go one piece at a time. You're going to find when you get into geometry that there are some things that are multiple steps. And those of you that like skipping steps and shortcuts, it's going to bite you. Okay? Start getting into the habit, especially in geometry, because it leads into algebra 2, pre-cal, and cal. You have to follow your steps. You have to go one step at a time. Okay? That's when you get into those tests where you'll have one question. It'll take you a page and a half to 2 pages to actually get your answer. Step after step after step. And if you make a mistake in step 2, you can do a whole lot of work for nothing. Okay? So just take your time. So we have negative root 12. What's the split on negative root 12? What times what? Good. Good square root, bad square root. The square root of 4 is 2, so this becomes negative 2 times the square root of 3. This becomes negative 2 times the square root of 3. We bring down our minus sign. Now we come over here and do 2 times the square root of 48. Again, we do a split. The square root of 48, you punch into y equals, but you can also kind of do a little bit of a cheat. And I'll show you what the cheat is. I know the bad square root is probably going to have to be square root of 3. Yeah. Otherwise, there'd be no point in us doing it. So you can put 3 here, work your way backwards, and see if you end up with a good square root. You do. So now the square root of 16 is 4. So we have 2 times 4 root 3, which is 8 root 3. So we put it back up here as 8 root 3. What is negative 2 minus 8? It is negative 10. Negative 10 square root of 3 is your final answer. Take your time and go slowly. One step at a time. Don't do all the work and then forget what negative 2 minus 8 is. Okay? Yep. Integer rules. Integers play a pretty significant part in geometry. Okay? You try number 10, please.
see the hot box, so.
So I end up with 5 root 5 plus 35 root 5, which is 40 root 5. Oh, and by the way, just, what?
Yeah, because you have to multiply the cell. You didn't multiply the, I didn't multiply the cell.
I keep typing this in like square root of all this. I keep.
Either y equals,
Yeah.
type in the number divided by x, and go to the table. Okay? All right, one more. So again, take your time. So over here, I'm going to find this first. So I'm going to do -3 times the square root of 98 first, which will cause me to split the square root of 98. And again, if you need help, you go to y equals, you type in 98 divided by x, you go to your table, you look down the y side, then you find your first good square root, you'll find it's 49. Because 49 times 2 is 98. And 49 is a good square root. So we have -3 times square root of 49 is 7 root 2, which gives you -21 times the square root of 2. So we have -21 times the square root of 2. By the way, the interesting thing is, just so you're clear, if you in your calculator type in -3 times the square root of 98 and hit enter, and then on the next line you type in -21 times the square root of 2 and you hit enter, it's the same number. You're just simplifying one of them. Just like 1/2 is the same as 4/8. Just a more complicated version. So now I'm going to do 4 root 32. So I have 4 times the square root of 32. What do I know is probably my bad square root? Yeah, 2. So I end up with 4 root, I put the 2 here, work my way backwards, that gives that 16, which is 4 times 4 root 2, which is 16 times the square root of 2. So I'll put my plus sign, and 16 root 2, -5 root 2. Okay? So just take your time. Remember, you had no homework, but you do have a test at the end of the unit. So make certain that you're doing your classwork and checking it. I'll go back to this and leave this up here in case anybody wants to fill out those notes that I just gave you. Yep. I don't have any water, I do not.
Okay.
So,